If I need to figure out to a certain level of confidence and I need to estimate my interval and make an inference about the calculation, how big should my sample be? A lot of times we give you the sample, that's what's in your information. Sometimes you have to figure out how large is your sample. So to do that, we have a formula. This formula, if you notice, uses NE, your Z, your standard deviation. It comes right from this one. It comes from this one. Again, it's just a transformation of that one. So we can find that one through this if we just transformed it, solved in terms of a different variable. If you solved in terms of n, you'd have to square both sides, obviously, get rid of your thing. So if I do this, I'm just going to rewrite this a little bit better. So if I take this and I cross multiply this, and you don't have to know how to do this, you just have to realize where it's coming from. And I divide by my E, I get this. And to undo a square root, you square both sides. Do you have to remember how to do this? No, I'll give this to you. And there is your transformed formula. It's kind of the same when we do your z-score and we transform it and solve for x. You don't use anything different. We just put it in a different order. You could plug it into this one and find n each time. You'd have to walk through those steps each time. So we take one and we transform. So this guy is the guy you're going to use when you find a sample, because n is your sample size. N is your sample size. That's the one we want to know. And I will give you that formula so you don't have to remember how to transform it. The one thing that I want you to remember, though, is whenever you find n, whatever n happens to be, we always round up to the next whole number. Because if n is this, if I need 72.1 people for my sample, say I'm asking, how many people go to college. If I need 72.1 people, could I ever find a 0.1 of a person? I'm in discrete numbers, aren't we? Discrete numbers when we count people. If I round it down to 72, I haven't reached 72.1. So therefore, we're always going to round your sample size up to the next number. I will have to survey 73 people to ensure that I hit that 72.1. I'll never hit a 0.1 person. And if I drop it down, I'll never hit 72.1. So rule of thumb is we always round up to the next whole number. Okay? Good so far? Okay. So in order to do this, we're going to use your formula. See if I can pull the formula there. You want to estimate the mean number of sentences. Remember we were doing this through this little section about their sentences, how long each sentence is in their advertisements. God bless you. You want to estimate the mean number of sentences in an advertisement. How many magazine advertisements should be included in your sample? It's asking me to find your sample. You have to realize which it's asking you for. This is what it's calling how many in your sample. What would your sample size be? How many should I look at? That's asking for a sample, not an interval. So once we see this, we know we need this formula. We still need your ZC, we need your standard deviation, we need your margin of error. You want to be 95% confident, so with 95% confidence, we have to find its ZC. We remember we do this, 95 in the middle, 2.5 on each side, then I got to turn this into a decimal. So when you do inverse norm, you should come out with 1.96. It's positive and negative, so we just use the positive. And if you did by accident use the negative, you're going to square it anyway. Once you square it, it's going to become positive. But remember to put the positive in. So that's our ZC. We know your ZC. Your standard deviation, we have to go back to example 1, where we had the mean and the standard deviation. The mean, I think, was 14.1. I can't remember what their standard deviation was. Their standard deviation was 5.0. I think this was 12.4, something like that, with the standard deviation of 5.0. Usually they'll tell you, but because they wanted us to go back to example 1, we just had to look it up. Here is another piece of information. Within one sentence, this means plus or minus. This guy is your margin of error. Within one, either plus 1 or minus 1. That's how you locate your margin of error. Within one sentence, so your margin of error is 1. So we plug all this in. We take this, we plug in your z-score, your standard deviation, divide by 1, and square it. Once we do this, this will give us how many we should need. When we do that, we get 96.04. And remember, I'll never get an advertisement of a 0.04 part of an advertisement. I have to note, you have to round up. If you drop it to 96, you never reach 96.04. So you have to round up to 97. So if I include in my sample 97 advertisements, that'll help me get within one margin of error, and I'll be 95% confident that I will find the population mean in that interval. It's working backwards a little bit. Usually we tell you how many are in your sample, you figure out your interval. This time we're working a little bit backwards. Okay? All right, you guys try it. Try it yourself at the bottom of the page. We still have the same ZC, we have the same standard deviation. They changed your margin of error to 2 within 2 sentences. What's that going to do to your interval when they change your margin of error? It's going to make it wider, right? It gave you more wiggle room. Instead of being plus or minus 1, you're plus or minus 2. It gave you a little bit more wiggle room. You're going to put your 2 in here. You're going to square the whole thing. God bless you.
God bless you.
And what did we come up with? What'd you come up with? 24.01, and what should I do to this? 25. Remember, you're not going to find a .01 magazine advertisement. You're going to either look at a whole one or not. And if I cut it to 24, as close as it is to 24, I would never hit 24.01. So you have to round up on this. So you're going to sample 25 magazine articles to come within 2 standard deviations of the mean. Didn't you give yourself a little bit more room in here? You gave yourself a little bit more wiggle room by changing your E, your margin of error. Now, I need you to recognize these things. It's still asking you to find how many are in my sample. That's how you know which formula to use. If it says how many in my sample, N equals. If it says find my interval, find my something else, whatever margin of error, E equals. Interval, X bar plus or minus 8. So we've looked at a couple of different things. We had to find your mean, your sample mean, your sample standard deviation. This came from your sample. We had to find out how many are in your sample. Sometimes we had to find it. We have to find a z-score related to your level of confidence. We need to know how confident you want to be, and we need to find the z-score related to that. We also need to find your margin of error. This is your wiggle room, your plus or minus. You're going to set your interval up this way. And when we do, we're going to get some number, like 10, less than, u, less than, I don't know, 15. We'll just call it at this. Our goal is to say that I can be 95% confident that my population mean will fall between these two numbers. That's the inference we make. We work with your sample and we infer something about the population. That's the whole point of this. That's what I want you to understand. Good? So Gunnar, if I say, why did we do this? Why did we find an interval? Yeah, just tell me what I just said. So that we can... Joe?
What?
What?
Oh, because, so you can see, like,
why did we go through all this? Why did we find this interval?
so you can find your margin of error.
Well, we need to find our margin of error because we need to estimate to a certain confidence level where our population mean will fall. That's exactly what you were going to say, right?
I just want to make sure you knew.
Thank you. So, okay, 49 says determine a sample size. Again, how do you know that you're finding your sample size? Determine your minimal sample size. It's right here. If you want to be 95% confident, so your confidence interval is 95, you need to find me a ZC for 95. So we knew it was 1.96. You assume your population is normally distributed with a standard deviation of 4.8. There's your 4.8. We got this guy. And look for your margin of error. It usually says within. There's your within, 1 unit. So your margin of error is 1. Do we care what our sample mean is? No, because all we need to do is find your sample size. We plug it in, we calculate, and we round up. Always round up. So you needed 89 in your sample to be 95% confident that you're going to fall within 1 margin of error, within 1 unit, whatever their unit was. Did everybody do this? Okay? It's the same ZC that we have on your chart. It's the same ZC that we take 95% in here. What you're left with is 5. Half of 5 is 2.5. Do an inverse norm on this and just keep it positive. Even if you accidentally put the negative in there, when you square it, you still come out with a positive. So even if you put the negative, it wouldn't be, in the long run, it wouldn't come out bad. Okay, this guy gave us a whole thing. They want to estimate the age within 1 year. There's your margin of error right there. You want to determine the sample size. This is your n equals. A 90%, you need to find the ZC for 90%. So 90 is here. How much is left? 10. How much in each wing? 5. So do an inverse norm on 0.05 and you get your ZC. They gave you your standard deviation, and yeah, this is a really small one. Very small one. Normally you don't keep a sample size of 4, but that is your minimum size required. Now, the nice part about this one was they kind of gave you, now change this to a 99%. All that's changing is your ZC. That's the only guy changing. Everything else stayed the same. So if I want to be more confident, what happened to my sample size? It got larger. I need more in my sample to make me be more confident. It's kind of, this way it'll take, like if I only had 4, what if that really wasn't a good representation of my population? Even though it was as random as possible. Maybe 10 gives me a little better feel for my population. And probably even more than that. But is everybody okay with finding your sample size? Okay. Now, tomorrow,